Welcome to the video that's going to show you how to do the problems from 6 weeks 2. The first three problems, 11, 12, and 13, are solving systems of equations, and it says that we can do this with any method. And so we learned several methods for solving systems of two equations and two unknowns. We learned how to do that by substitution, elimination, graphing, or using the Desmos Matrix. And so for 11 and 12, I'm going to show you graphing on Desmos, but when we get to number 13, where we have three variables, we will have to use Desmos Matrix. So let's go ahead and take a look at number 11. And our solution is just basically a point on the graph where the numbers are the same. The ordered pair is the same. So it's the intersection point. In this case, -4, -7. So that is the solution to this system where they cross. Let's go back and say that our point is -4, -7. Remember that it's an ordered pair, an x and a y, so it does need to be in parentheses with a comma in between. Let's do number 12 the same way, and then we'll do 13 on the calculator. So number 12, we'll take a look at. I've also put those in. These lines are pretty close together. I may need to kind of zoom in a little bit. I can tell that the intersection's somewhere there, so just touch it and you'll get the gray dot, and then the second time you touch it, you'll get the point. It's at -5, -1. So that is our solution. It's where both equations are true. So let's put that as our answer. The intersection that we found in Desmos was -5, -1, and so that's our final answer. Remember to put it in parentheses because it's an ordered pair. This next one, we are going to need to use Desmos Matrix calculator instead because we have three variables and regular Desmos graphing calculator doesn't do 3 dimensions. So let's go ahead and write what we're going to be putting into the elements of our matrix so that we're sure about that whenever we jump over to Desmos Matrix. So 3, 1, 1, and then 0. We have 1, 2, -3, and 0, 3, -4, 11, and 0. One thing that you want to be sure of as you're doing this is that you want to make sure that you account for everything being in the same order. If it's not in the same order, or if you have something besides a number over on this right hand side, you need to move things around to get everything into the standard form so that you can properly write the negatives and positives of your matrix. So now let's go ahead and take this over to Desmos Matrix and put it in. Here we are in our Desmos Matrix calculator, and we want to create a new matrix. We have more than a 2 by 2. We have a 3 rows and 4 columns matrix. So we want to do that first to edit the size of the matrix and then start putting in our elements. Once you've entered all of your elements, you want to go to the next line and click the RREF button in the lower left. We want to do a reduced row echelon form, RREF, of our matrix, which is A. So go ahead and click on A to tell it which matrix. And now we have our reduced row echelon form matrix. Let's copy this into our review and then compare it to the possible types of solutions that we have. All right, from Desmos Matrix, we had our reduced row echelon form of our matrix, and it was a 1, 0, 1, 0, 0, 1, -2, 0, and 0, 0, 0, 0. Now, it didn't have the colons in there, but we know that they're there to indicate the equal signs. Now, the first thing that we want to look for is to see if we have a diagonal row of 1s. If we have a diagonal row of 1s, then our solution becomes the numbers along the right-hand side. So I'm going to look across here. I have 1, 1, but then I have a 0. So I do not have a diagonal row of 1s. That means that there is not a single solution. So now what we need to do is look at the last row, which is all zeros, and compare that to no solution up here and to infinite solutions. And all zeros is basically saying that 0z is, or in this case I guess t, is equal to 0. And so that means that it's a true statement and that we have infinite solutions. If instead we had a 1 here instead of a 0, then that would indicate that we had no solutions. But because we have an entire row of zeros, it's infinite solutions. So infinite solutions is the answer. All right, this next one we want to describe the transformation starting with our quadratic parent function, x squared, represented by g, and then graph the function. We only have one thing that's different from our parent function, it's that 3. It's not inside parentheses, so we know that it's vertical. And so in this location in front of x, and a number bigger than 1, this is a vertical stretch by 3. Vertical stretch by 3. We want to graph this. So our parent function first. Let's graph our parent function. It starts at 0, and then, because if we plug in an x value right here of 0, we're going to get 0. So it starts at the origin. If we plug in an x value of 1, we're going to get 1. And if we plug in an x value of 2, 2 squared is 4, so we would go up to 4. And that'll give us a few points to start our graph. We could maybe do 3 and 9 as well, just to get us an extra point there. Remember, you need at least 2 points on each side of the vertex. So we can draw half of our parabola here, and then mirror across the axis of symmetry to get some more points on the other side and draw the other half. This is our our f of x. This is f, the one that we started with our parent function. Then we want to do the transformed one where we vertically stretch by 3. So again, we can just plug numbers in. We're going to start here, plugging in values for x. So if I plug in a value of 0 for x, I'm going to get 0. So we're starting off in the same place. If I plug in 1, I get 3. If I plug in 2, I get 2 squared is 4 times 3 is 12. So I'm actually off of my graph by a couple of tick marks. I'm going to put those tick marks there and just say that that's about 12 so that I can graph my function. Notice that it's skinnier because it has stretched toward the vertical axis or the y-axis. By reflecting over the axis of symmetry, I can get points on this side and draw my little skinny parabola there. All right, number 15 wants us to write an equation of a parabola in intercept form, and we're given intercept form. Remember, P and Q are our intercepts, P and Q. All right, so in order to write this form, we need P and Q. 4 and 6 are our intercepts, so I'm going to call one of them P and one of them Q. So P is equal to 4, Q is equal to 6. Could have written them opposite as well. We also, in order to write in intercept form, need another random point. You could pick any point where the graph goes through an intersection. I'm just going to go ahead and pick the vertex. That's a nice convenient point to pick. So I'm going to pick this point, which is at 5, 1. And so in order to write the equation of this parabola, I'm temporarily going to say that x is 5 and y is 1 in order to plug into my equation here in intercept form. So I'm plugging into the equation I've been given with my x and y and p and q. The only thing I won't know is a, but I can solve for it. So 1 is equal to a. I don't know a. 5 minus 4, a minus p. Remember, there is a negative sign in there, so be sure you put it in. And then again, x, which is 5, minus q this time, which is 6. Let's do the math. We're going to have a times 1 times negative 1, which is negative 1a. Let's divide out that negative 1. And so that leaves me with a is equal to negative 1. So now that I know a, I want to write my final equation plugging in a, p, and q, leaving x and y as variables. So we have y is equal to -1, but we would just usually write that as just a negative, x minus 4, x minus 6, and that is our intercept form, also known as our factored form once we got into factoring in the third 6 weeks. All right, problem number 16. We are going to graph this function and label the vertex and axis of symmetry. So you can graph this a couple of different ways. You can either notice that this is vertex form. I've written the equation for vertex form off to the right, or you can also use Desmos. So when we have vertex form, our h value is located inside. Notice that negative sign in the equation over here in pink, and k is here. So h is equal to -5 since we see a +5 in the equation, and k is equal to 2. So I can plot my vertex at -5, 2 right here. I can also get more points on my graph by plugging in values for x right here. Since we just practiced graphing by hand a couple of problems ago, let's go ahead and do this one in Desmos. All right, I have plotted my function in Desmos right here, and we have our vertex point that we just already figured out from our vertex form, but let's go ahead and grab a couple of other points. So we have this point and this point, which are our intercepts. We have one at, it looks like -4 and 0, -6 and 0. And then the next time that I see that we've crossed the graph is -6, and that occurs at -3. So we can plot a point at -4 and a point at -3, reflect those, and then that will give us the information that we need. Let's transfer the points that we got in Desmos over here to our graph. So we had a point at -4, 2, and at -3 we were down at -6. Remember that we already plotted our vertex at -5, 2, and so that gives us our axis of symmetry, and we can reflect to get our other points and go ahead and draw our graph. So here is our graph. And then the other things that we wanted to do are label the vertex and the axis of symmetry. We've already drawn them, but let's label them. -5, 2 is our vertex, and our axis of symmetry is at x is equal to -5. Let's move to number 17. So number 17 says that the table shows the height of a monster truck x seconds after jumping off of a ramp. We want to know what type of function models the situation best, and then estimate the height of the truck after 0.75 seconds. If it goes up and then down, notice that our y values increase from 6 to 8.4 and then decrease back to 6. So we're going up and then down. That means it's got to be a parabola. A line doesn't go up and then down. So it's a parabola or a quadratic. So the table you get by doing the plus sign and then selecting table, put in your x's and y's. We want to make this a quadratic because we know we go up and then down. And so we want to do a standard form of a quadratic, which is y equals ax squared plus bx plus c. Remember on Desmos, there's a couple of little funny things where you have to do the y1 and x1 just like your table, and you want Desmos to give you the approximation or the answers for your a, b, and c. So you put that little squiggle or tilde sign in order to get that. So those are the kind of funny things that we have to deal with there. And so once you put that in, you're going to get your A, B, and C value listed there as the parameters. The second part of this problem asks us to estimate the height of the truck after 0.75 seconds. So a couple of ways to do that. One is to have Desmos draw a vertical line at x equals 0.75. That's what we want. Our x values are our seconds, and we want it at 0.75 seconds. So that's what I did in the third box here. You can see that I said x equals 0.75, and it drew that red line. if I just look at the intersection, remember that's like a solution to our system, I can see that at 0.75 seconds, I'm at 7.86 feet. There's a second way to do this algebraically, and I'm going to show it to you here in a second. But first, let's go ahead and write our equation based on this A, B, and C value. And write our equation. Rounding to the hundredths, and you'll know on the test how you need to round because your answers will be rounded a certain way, where it may tell you. We have negative 2.06x squared plus 4.11x plus 5.93. That is our equation. We already came up with our y value being 7.86 feet, but let me show you the algebra way to do that. All you do is plug in 0.75 everywhere that you see x. So we're substituting for x with 0.75. So the first time it's squared, and then the second time it's just 4.11 times 0.75, and then we still have that c value, that 5.93. Put this whole thing into your calculator just like you see it with the parentheses and everything, and you will also get 7.86 feet. So either way, Desmos or calculator will get you that answer. All right, let's look at number 18. We want to write a system of inequalities that it best represents the shaded region. I want to remind you that the equation for a line in slope-intercept form is y is equal to mx plus b. We're going to be using inequalities, but the equation is kind of where our starting point is. So b is our y-intercept and m is our slope. Now, don't let straight up and down vertical lines, or in this case, perfectly right to left horizontal lines, confuse you. I know that some students struggle with figuring out if you need to have a y equals or an x equals or what. Here's the way to tell. First, let's label these. So we're going to do 1, 2, and 3. Our first line is a horizontal line, so let's deal with that. Notice that that line never crosses the x-axis. So we can't have an x equals anything because it doesn't ever even touch the x-axis. So it has to be a y. Okay, so let's take a look. It's a solid line. Remembering back to our rules for this, a solid line means that it has the or equal to part to it. Notice also that the shading is down below this line. So if it's below, it has to be a less than or equal to. What is it less than or equal to? 4. The value right here, 4. Our second one is also a completely horizontal line, but notice that it's dashed. That means that we're going to have no or equal to part, just a less than or a greater than. Which one is it? Well, the shading is above, so it has to be greater than. So shading above gives us a greater than. What is it greater than? This line crosses at -1. All right, number 3, this is a sloped line, so it goes through the x and the y, so we know we're going to have an x and a y. So here's where this y equals mx plus b comes in. We're going to start with y. If we take a look at where this dashed line crosses the y-axis, its y-intercept is at a +1. Notice that the shading goes up above that intercept. So if it's above, it's a greater than. Above is a greater than. It's not or equal to because it's a dashed line. Slope. If we started our y-intercept at 1, we have to count up 3 in order to go over 1 and land back on our line. So up 3 over 1, that's a slope of 3x, and we said our y-intercept was 1. And those are our equations. I suggest that here you go ahead and look at Desmos, put these equations in, and make sure you get a graph that looks like the one in the problem. If the shading seems backwards or something, go and look at your inequality symbols and check it. Okay? So put all of those into Desmos and make sure that you get a graph where the darkest shaded region is the same as the region that's shaded here. All right, problem number 19 is kind of an open-ended problem. On your test, instead of saying what is a solution to this system of inequalities, it's going to give you 4 points and ask you which one is a solution to this system. So your A, B, C, D answers will all be XY coordinates, and you're going to want to figure out which one of those is a solution. And remember, for a solution, when you look at your graph on Desmos, you want to look at an area where all the shading overlaps. So for our purposes, we're just going to do a sample solution. We're going to look at where the shading all overlaps and pick a single point. It could be any point. So we will do a sample solution by putting these inequalities into Desmos and seeing where they all overlap. So let's take a look at that. I'm going to turn these off and look at them one at a time. So our first equation, y is less than -5. Notice we have a dashed line because it's just a less than, and it's below -5. When you put, so that's red, and then when you put this blue one on, you kind of get a purple area where the two graphs overlap. And then finally, we're going to see a green area pop up. So anywhere where the 3 pieces overlap could be a solution. I'm just going to pick a random point. Starting at 0, I'm going to go over 2, and then down somewhere past -5, maybe -7. Okay, again, this is a random point. On your test, you'll have 4 possible solutions. You're going to want to see which one falls in that overlapping shaded region. So 2, -7 is a sample solution. Not the only solution by any means, but it's a sample solution. All right, we're going to do one last problem, but we're not going to do number 20. 20 and 21 actually have to do with the third 6 weeks. We're going to jump down to 22 and do this one. All right, so jump down to problem 22. We'll come back and do 20 and 21 in the next video. This is equation of a parabola, and it's using the focus, okay? Remember, if we know the focus, we can write an equation. It's actually a very simple equation from there. So our parabola opens up, and if it opens up or down to where our opening is in the y direction, we use the version of our focus equation that starts with y. And the equation is this: y is equal to 1 over 4p and then x squared. The opposite equation, if we had a parabola that went left or right, your x and y just switch. All right, our focus is located at 0, 2, so this is p. It's always the non-zero value in that focus point. So just plug that in. 4 times 2, x squared, and then finally it's 1 over 8, x squared. And that's your final answer and also the finish of this video.